Welcome to all. Today we shall solve GATE 2024 mechanical paper and the problems which are associated to applied mechanics and design, that is engineering mechanics, mechanics of materials, theory of machines, vibration and design of machine elements. So let us start. For a ball bearing, the fatigue life in million of revolutions is given. L is C by P to the power N, we know that, where P is constant applied load and C is the dynamic load carrying capacity or dynamic load rating. Which one of the following statement is true? N is 3, it is a ball bearing, so we know that N is 3 for ball bearing and N is 10 by 3 for roller bearing. So it is a ball bearing, so N must be 3, that is correct. Assuming that inner race is fixed and outer race is revolving, that is incorrect. So the next part is incorrect because in is 3 and inner race is rotating, whereas outer race, say this is inner race and this is outer race is fixed, and whereas inner race is rotating. So this is N is incorrect. Then N is 3, assuming that outer race is fixed and inner race is revolving. So this is the correct one. We have studied during our main course or full course. So this is very easy problem. Now let us move to the next problem. The kinetic energy or change in kinetic energy delta E is given, or delta, we have used delta Ke kinetic energy, say no issue. So delta E of an engine is 300 joule. Minimum and maximum shaft speeds omega mean and omega max are given. Omega mean is 220 radian per second and omega max is 280 radian per second. Assume that torque time function is purely harmonic. Okay, torque is fluctuating. To achieve a coefficient of fluctuation, it should be coefficient of speed fluctuation, that is Ks is 0.05. The moment of inertia of flywheel to be mounted on the engine shaft is to be determined. We know that is delta E is I omega average square into Ks. Omega average square into Ks. So putting that value, I has to be determined. What is omega average? Omega average, we know that omega max plus omega mean divided by 2. So here 280 plus 220, 500 divided by 2, that is 250 radian per second. So 250 square into value of Ks is given 0.05. So I, from this you can easily calculate I becomes 0.96. What will be the unit of I? Kg into meter square. Now you can check that this option is correct, but I want to say something about this problem. Delta E is also half I omega max square minus omega mean square, and the value of Ks, so you can apply this equation also, but here it is one condition is given to achieve coefficient of fluctuation, and coefficient of fluctuation can be also determined from this velocity range, that is this is omega max minus omega mean divided by omega average. So we know the value, all values, omega average value is known from these two value, but if we put these two values, that will not come this. So this is a contradictory problem. If you use this equation, the answer will come to this. So this is the contradiction about the problem. So you can use this equation also, but I don't know why Ks, that is operating Ks value may be different. Okay, now let us move to the next problem. A ram in the form of rectangular body. So this is the ram in the form of rectangular body. L is given, L is 9 meter, and value of B is also given, that is 2 meter. Is suspended by two parallel ropes. This is the parallel rope, two parallel lobes, and it is fixed here. This is fixed here. Assume the center of mass of the body is geometric center. So center of mass lies at the geometric center here. G is 9.81 meter per second square given. For striking the object P, this is the object P, with a horizontal velocity, when it strike here, that is the dotted position, it strike here, the horizontal velocity V is 5 meter per second. What is the angle theta? What should be the angle theta? With the vertical form, which the ram should be released from the rest. So here the ram was at rest. Now what is the height drop of the ram? This is this height. So applying the principle of conservation of energy, mgh should be half mv square. Gravitational potential energy is converted to kinetic energy. So m can be cancelled. That is, value of g is given. So is v square by 2g. So let us put the value. You will get the value of h. H should be what? V square. V is 5. That is 25. 2 into 9.81. 2 into 9.81. From this you will 1.274 meter. H is 1.274 meter. So from this triangle, you can easily calculate the value of theta. Even cosine theta is what? Say this is O, this is A, this is B. What is cosine theta? OA by OB. What is OA? OA is 7 minus H, because this will come to here, so this OA is 7 minus H, 7 minus 1.274 divided by 7. Now calculating this, you will get theta is 35.11 degree. Now let us check the options. Option C is the correct one. Now let us move to the next problem. A linear spring mass dashpot system, mass M is 2 kg, set in motion with viscous damping. Viscous damping is applied. If natural frequency is 15 Hz, omega n, or f, sorry, it is given in Hz. So f is 15 Hz. That is omega n is 2 pi into 15 radian per second. The amplitude of two successive cycles measured. Amplitude of two successive cycles, that is, say this is for n plus 1 is 7.75 and xn is this is for n, and after that n plus 1 cycle it becomes 2. That is, we have seen the amplitude is reducing cycle by cycle. So here it is xn and here it is xn plus 1. Okay, what is the ratio of logarithmic ratio of this? That is, we know xn plus 1 is what? 2 pi zeta root over 1 minus zeta square. So zeta is the damping factor. Now let us put the values. Ln 7.75 7.2 is 2 pi zeta root over zeta square. That is, from this you will get 0.0736 is this much. Sorry, 2 pi zeta over 1 minus zeta square. Now squaring both sides, you will get 0.00541 minus zeta square is 4 pi square zeta square. From this equation we can easily find out zeta, the value of zeta. Let me erase this and do it here. So value of zeta becomes what? 0.0117. Now what is to be determined? The coefficient of viscous damping. The coefficient of viscous damping, we know that zeta is C by Cc. So we have to find out the value of C. C is zeta. Cc is root over 4k m, that is zeta 2 m omega n. 2 m omega n. The value of m and omega n is given. So C becomes zeta, value of zeta 0.0117 into 2 into m is also 2 kg into 15 into 2 pi. 15 into 2 pi or 2 pi into 15 is the omega n. Now calculate this, you will get a value 4.38. 4.38, and SI unit is Newton second per meter. It has been asked to calculate in this, so the answer is 4.38. 4.38 our answer. It is very close to 4.41, so option A is the correct one. Now let us move to the next problem. Which one following failure theories is most conservative design approach against fatigue failure? Soderbergh line. Let me explain here. This is sigma mean axis, this is sigma amplitude. Okay, this is abscissa, this is coordinate. Now let me draw all the AC, SYT, SUT, SUT. Now this is Soderbergh line, this is Soderbergh S, this is Goodman line, then yield line, this is the yield line, this is yield line, and what is Gerber line? Gerber line, this is the Gerber line. So which one is the most conservative? That is this, Soderbergh. Soderbergh is the most conservative line. Okay, Soderbergh line, this line joining AC and SYT is the most conservative. So which option is correct? That is the option of Soderbergh line is the correct one. So the inner one, that is the inner one, is the Soderbergh, then it is yield line, then it is Goodman line, and this is Gerber diagram. This is Gerber, Gerber. Okay, we have studied this in our full course. This is a very simple problem. Now let us move to the next problem. A rigid massless tetrahedron, this is the tetrahedron by shown in the red color, this is placed such that vertex O, this is the vertex O, is at the origin. Okay, this is the origin, and the other three vertices A, B, C lie on coordinate axis as shown in the figure. The body is acted on by 3-point loads, of which one is acting at A. So one is acting at A along x-axis. So this is one force. Another at point B, another at point B along y-axis. Very clear? Okay. For the body to be in equilibrium, the third point load acting at point O must be along which direction? So what is the resultant of these two? What is the resultant of these two? If so, resultant of these two will be like this. Say this is the resultant force which lies in which plane? This is x, this r lies in xy plane. Now we know that for equilibrium, summation of all forces is 0 and summation of all moments are 0. Now if this is the resultant force, then at point O, if the body remains, the summation of all forces remains 0, then we have to add one force which is opposite to R. So opposite to R means it must lie on xy plane. So this is R prime. R prime must passes through O and it must lie on xy plane. Then only these two will be nullified. Okay, it must lie in xy plane but not along x and y axis, because resultant is not along x and y axis. So this force which has to be applied, that must also not lie about x and y axis. So this is the answer to the problem. Option B is the correct one. Now let us move to the next problem. Which of the following beams are statically indeterminate? So here for the first beam, this is a roller joint. So single Ry will be there. Here another, say this is Ry1, this is Ry2, and this force, that is Rx. But here along x axis no force is there, so Rx must be 0. So we know that there are three equilibrium equations and summation of moments is 0. Okay, so as there is no force along x, so this equation becomes redundant. This equation becomes redundant and Rx is 0. Always for all beams Rx is 0. So we have two active equation. So if unknowns are 2, we can solve this and that will be statically determinate, otherwise statically indeterminate. So there are two unknowns. Already we know that Rx is 0 as this equation is redundant. So two unknowns can be solved. So this is determinate. So this is statically determinate. For next, this is same thing happening. Here 1 Ry2, here 1 Ry1. So this is also determinate. Now third one, for third one Ry1, Ry2, and here also another Ry3. So how many unknown reactions? 3 unknown reactions and 2 active equations. So this is indeterminate. This is indeterminate. Now third one, here 1 Ry1, here also this is a fixed support Ry2 and 1 moment, reaction moment. So here is a sorry, here is also there are 3 unknowns. So this is also indeterminate. So these two beams C and D are statically indeterminate. So the answers will be C and D, both are statically indeterminate. These things we have done several times in our full course. So who have confusion, I suggest you to go through my full course.
Are you a GATE mechanical aspirant? Then you are at the right place. Join Mechanical Academy, your ultimate gateway to IITs, and PSUs. Meet with our expert faculties, their details are shared here. Both of them having more than 10 years of teaching experience for GATE. We provide video lectures, live classes, solution of previous GATE 20 years papers, study materials in well documented book form, doubt solving, and last but not the least, test series. Your dreams course starts here at Mechanical Academy. For details, WhatsApp 8777 Please follow our YouTube channel and books. Links are provided at the description box. So, looking forward to meet you soon.
The levy type A train, this is a gear train illustrated in the figure. This is the figure. Has gears with module. So module is given 8 mm per 2. Gear 2 and 3 have 19 and 24 teeth. So N2 is 19 and N3 is 24. This is gear 2, this is gear 3. Gear 2 is fixed. Gear 2 is fixed. That is, we can write omega 2 is 0. And internal gear 4. So this is internal gear. This is internal. Why it is internal gear? You can see here, that is gear 3. This is the gear 3 mesh with gear 4 at its internal surface. So gear 4 is an internal gear which rotates, that is omega 4. It is given 20 revolution per minute counterclockwise, CCW, and counterclockwise we have considered positive. The magnitude of angular velocity of the arm. What is arm? 1 is arm. So what is omega 1 has to be determined in revolution per minute. Okay. So this type of gear train problem we have solved several times, and the suitable method is the tabular method. Before that, we do not know the number of teeth on gear 4. So let us first determine the number of teeth on gear 4. So if I draw the entire gear train, that will be like this. So here, this is gear 4, this is gear 4, and in between here you can consider that this is another gear 3 is there. This is not present, but for dimensional measuring we have considered. So what will be dp4? That is, dp4 means pitch diameter of internal gear 4, that is dp2 plus 2 dp3 dp2, this much, plus 2 into diameter of gear 3, pitch diameter of gear 3. So that is equal to 8 into 19 plus 24. If number of teeth on gear 4 is N4, then 8 into N4 is what? 8 into, sorry, I am extremely sorry. This should be 2. 2 into 24, because 2 into dp3. So 8 into 19 plus 48. So N4, from this we can calculate N4. N4 is 19 plus 48, that is 67. So number of teeth on gear 4, number of teeth on gear 4 is 64, that we have determined. Sorry, 67. 67 we have determined. Now you can easily find this problem by using tabular method. What is this? That is conditions, then arm, or I am shortly writing 2, 3, 4. These are the gears. Now what is the first conditions? All gears are locked to the arm. At this condition, all will have same velocity, same angular velocity, x, x, x. We have done this several times in our full course, and I have explained why it is happening like that. Then arm fixed. If arm is fixed, then rotational velocity of the arm is 0. 2 will rotate at y. When there is arm is fixed, let us back to the gear train, that if Let me erase all these things. Okay. If 2 rotates, with y, 2 and 3 are externally meshed, so 3 will rotate opposite direction and their number of teeth is given, so we can determine the speed of 3. That will be minus because it will rotate in opposite direction. Speed will be reduced in this ratio y. Next, what will be speed of gear 4? It is internally meshed with gear 3. So 3 and 4 will rotate in same direction. So the direction, the sign remains same, that is 19 by 24 into 24 by 67y. Okay, now let us find the resultant. What is the resultant? X, here x plus y, here x minus 19 by 24y, 24 will be cancelled, x minus 19 by 67y. Now it is given that gear 2 is fixed, omega 2 is fixed. So omega 2 is x plus y is 0. That is y is minus x. And we have to find out the speed of the arm. What is the speed of the arm? That is what is the value of x. And this is also given omega 4. Omega 4, that is x minus 19 by 67 y is, it is given 20 counterclockwise direction. That is x minus y is minus x, so this becomes plus 19x by 67 is 20. That is 67 plus 19, 86x by 27 is 67 is 20. That is x is 67 into 20 divided by 86, and that becomes 15.58. As it is positive, that means counterclockwise direction. So uh, this is the angular velocity of the arm, that is 15.58. So this is the answer to the problem. Now let us move to the next problem. Now let us solve this problem. A horizontal beam of length 1200 millimeter, that is nothing but 1.2 meter, pinned at the left end, say left end is A, and resting on a roller at the other end, say other end is B, as shown in the figure. A linearly varying distributed load is applied to the beam, that is shown here, and intensity here at the free end, at end B, sorry, at end B is 100 Newton per meter. The magnitude of maximum bending moment acting on the beam is to be determined. So what is our first task? Our first task is to determine the reaction forces at the supports, RA and RB. Now what is total load? What is total load on the beam? Total load is half into, here intensity is 100 into length is 1.2, that is 60 Newton. And that will act, that 60 Newton will act from where? From 1/3 of total length, that is 1/3 of total length is 1/3 into 1.2, that is 0.4 meter. So this is 0.4 meter. Now how to calculate RA and RB? RA from equilibrium, equations of equilibrium is 0. Now let us take a moment about A. If I take a moment about A, then RB into 1.2 minus 60 into 0.8. This becomes 0.8. This distance is 0. So from this you will get RB is 60 into 2 by 3, that is 40 Newton. Then RA is 20 Newton. So we got the values. Now bending moment will be maximum. The value of bending moment will be maximum where? Where shear force is 0. Sorry, where shear force is 0. Now if I want to calculate the position of shear force where the position shear force is 0, if I draw the shear force diagram, Vx. So Vx at point A, here, point A, that is 20 Newton. Okay, 20 Newton, because Ra is 20, so at point A it is 20. Now where it is 0, say I do not know, at any location x, the value of Vx is 0. At any location x, the value of shear force is 0. So what is the value of shear force at this point? Say this is point C. So this is point C, and sorry, let me write down, Vc is 0. So Vc is what? Va minus total load under this, total load under this. If this distance is x, here the intensity of load becomes 100x divided by 1.2. So the intensity of the load is this. Then what is total load? There is a triangular area, so half into intensity is 1.2, and length is x, and length is x. So x, this is the total load, this is the area, total area of the load, and that is the total load. So you can determine the value of x from here. You can determine the value of x from here, that is 20 minus 100 x square 2.4 is 0. That is x square is 20 into 2.4 is 48 by 100. 48 by 100, 0.48, and from this you will get x is 0.6928 meter. So at x equal to 0.6928 meter, shear force is 0, Vx is 0, and we know that there the bending moment will be maximum. Where shear force changes its signs, there then at that location the bending moment will be maximum. So we have determined that at this location bending moment is maximum. At x equal to 0.6928, bending moment is maximum. Now let us find what is the value of bending moment at any section x, because this loading is continuous. So take any section. This is 20, Ra is 20. The intensity becomes 100x 1.2. The bending moment is to be determined, that is mx. Okay, now what is the resultant load? If this is x, then resultant load will act somewhere here, and that is half 100x 1.2 into x, that is x square. So mx minus 20x plus half 100 x square 1.2 into this distance will be 1/3 into x, that is 1/3 x is, that is bending moment becomes 20x minus 100 x cube 7.2. 7.2. Now let us put the value of x where bending moment is maximum, that is 0.6928. X equal to 0.6928, that is 20 into 0.6928 minus 100 0.6928 cube divided by 7.2, and calculating this you will get 9.237 Newton meter. So this is the answer to the problem. Now let us move to the next problem. So this is a very conceptual problem. Now let me read out the statement of the problem. At the instant when OP is vertical, this is O and this is P. OP is vertical, this is P, and AP is horizontal, this is A, this is P. AP is horizontal. The link OD, this is link, this is O, this is D. This link this link OD is rotating counterclockwise direction at a constant rate omega is 7 radian per second, this omega, and which is in counterclockwise direction. Pin P, this is the pin P on link OD, this is O, this is D. On link OD slides in the slot BC. This is B, this is C. So you can see the slot. This is the slot BC of link ABC. This is A, this is B, this is C, the triangular link ABC, and which is hinged at A. Okay, and cos, due to this rotation, due to omega, the ABC will rotate clockwise direction given, that is, and cause a clockwise rotation of link ABC. Okay, magnitude of angular velocity of link ABC at this instant has to be determined. Now let me first define the mechanism. Okay, say fixed link is 1. Say fixed links are denoted by 1. These two are fixed link. This is the fixed link. Now the input link which is rotating, that is 2. This is link number 2. OD is link number 2, and say the rotational speed is omega 2. Let us consider that omega 2 is 7 radian per second. Now let us come to here. This is the concept here. Now this pin which can translate along this direction, translate on ABC link number, as well as it can rotate, So this is neither a revolute pair nor a prismatic pair. So what we can do here, at this case we shall consider another link here, that is another slider. We are considering that there is a slider, and that slider is, we have considered the green color, that is a slider. The slider is link number, what is the link number? That is link number 3. The slider is link number 3. So rotating link is 2, slider is 3, and this link ABC, this triangular link ABC is link number 4. Now this becomes a 4 link mechanism, and let me explain the motion. That is, link 2 has a pure rotation about O or O2. It is hinged at with the fixed link, so it can pure rotation. Okay, link 3, that is the slider which can slide along link 4. Okay, and link 2 and 3 are connected by a revolute pair here. This is the revolute pair, this P is the revolute pair. Okay, P is the center of the revolute pair. Okay, so 2 3 can rotate joined by revolute pair, 3 and 4 are joined by prismatic pair, and 4 is connected to the fixed link 1 here by a hinge joint. Now let us consider, this is our, we should concentrate about this point P, this point P, and you can imagine that point P lies on 3 bodies. It lies on body 2, is lies on body 3, as well as is lies on body 3. So there exist 3 instantaneously coincident points. They are P2, P3 and P4. That is point P which is on body 2, point P which is on body 3, and point P which is on body 4. This we have discussed several times in our full course. Those who have gone through my lectures, this problem is very easy to us. Let me define once again here also. Now body 2 and 3 are connected by which? Connected by a revolute pair, that is the pin joint revolute pair. So 2 and 3 always remains coincident. 2 and 3, among these 3, 2 and 3 always remain coincidence. That is, if this body 2 rotates by some amount, P2 and P3 lies together, whereas P4 at this point, that is P on body 4, will shift. So these two are always remains coincident, and at this instant, right now, for this instant, these 3 points are instantaneously coincident. If they always remains coincident, that means what? That is, velocity of point P on body 2 is equal to velocity of point P which is on body 3. These three are equal. Now let us consider about point P3 and P4. Point P3 and P4. What is the velocities? Vp3, that is velocity of point P which is on body 3, that is equal to velocity of point P which is on body 4 plus velocity of point P relative to velocity of point P3 relative to point P4. Now, what is Vp3? Now, let us Vp3 is also equal to Vp2. So, let me write down here Vp2 is Vp4 plus Vp3 by 4. Now, what is Vp2? If we consider that point P is on body 2, then what is the velocity? Let me erase these things. What is the velocity? 2 is rotating with omega 2. 2 is rotating with omega 2. So, this is nothing but Vp2. What is Vp4? Vp4 will be perpendicular to that is along link 2 or along OD, that is perpendicular to AP. And so this is the direction, we do not know the value. Okay, this is the, we know the direction only. We know both direction and magnitude of Vp2 because omega 2 is given and OP is given 150 mm. Now, what is about Vp 3 by 4? 3 by 4, that is relative velocity of point P3 with respect to P4. Now, what is the relative velocity of 3 with respect to 4? 3 can only slide along this direction. So, this is the direction of Vp 3 by 4. So, my equation is Vp2 is Vp4 plus Vp 3 by 4. You can give the vector notation, okay, because these all are vectors. Now, what is, let me draw the velocity diagram right now. Now, Vp2 is known, this is Vp2, this is Vp2. What is the value of Vp2? Omega 2 is given into 150. Omega 2 is 7 into 150. This much millimeter per second. Now, what is Vp4? Vp4 AP is horizontal, it is given. So, Vp4 will be perpendicular to that, that is Vp4 is also absolute velocity, Vp2 absolute, and this is the relative velocity. Now, what will be the direction of relative velocity? We know that relative velocity is sliding velocity that makes an angle 60 degree to the horizontal. That is, it will make an angle 60 degree to Vp2 also, because Vp2 is, now these two directions are known only, not magnitude. Okay, so what will be the velocity diagram? That is, velocity diagram will be like this. Okay, sorry, here may have a, let me draw it. Okay, so this is Vp4 and this is Vp3 by 4, and this angle is 60 degree. Now, if I put, that is tan 60 degree is Vp4 by Vp2. The value of Vp2 is known. Vp4 is Vp2 7 into 150 tan 60 degree is root 3. Now what is Vp4? If the angular speed of ABC or link 4 is omega 4, which has to be determined, that is omega 4, then omega 4 into AP is another 150. So omega 4 into 150 is 7 into 150 into root 3. That is omega 4 is 7 root 3, which is equal to 12.124 radian per second. Okay, so this is the way to solve this problem. This is very easy. I have uh, discussed so many things, but uh, who have studied my full course class, they can easily draw this velocity diagram and solve it very easily. Now let us move to the next problem. Okay, a solid massless cylindrical member, this is the cylindrical member of diameter 50 mm, 50 mm diameter, is rigidly attached at one end. Here it is rigidly attached at one end, subjected to an axial force P. P is 100 kilonewton and a torque T is 600 newton meter at the other end as shown. Assume that the axis of cylinder is normal to the support. Axis of the cylinder is normal to the support. Considering distortion energy theory with allowable yield stress SYT is 300 MPa. The factor of safety in design has to be determined. So due to P there will be a normal stress. If this is x direction, sigma xx will be what? That is P by pi by 4 d square. That is 100 into 10 to the power 3 pi by 4 into 50 square. Newton per millimeter square is what? Newton per millimeter square is MPa. So sigma xx will be 50.93 MPa. You can calculate it. Next, due to torque T, there will be a shear stress. What is the value of shear stress? That will be tau xy if this is x direction, and if this is y, then tau xy will be 16T by pi dq. Then tau xy, let us find, that is 600 Newton pi into 50 cube. 50 cube, and here torque is in Newton meter. So if I make it Newton millimeter, then divided by millimeter cube, then it becomes Newton per millimeter square. So let us multiply by 10 to the power 3, it will come in MPa. So let us find the value. What is the value of tau xy? And tau xy you will get 24.45 MPa. Now according to distortion energy theory, that is the von Mises theory, we know that SYT is root over sigma 1 square plus sigma 2 square minus sigma 1 sigma 2. Sigma 1 and sigma 2 are principal stresses. Now what is the value of principal stresses for this case? We know that sigma 1 comma 2 is sigma xx plus sigma yy. Here sigma yy is 0. For this case sigma yy is 0. So only sigma xx is there. That is sigma xx by 2 plus minus root over sigma xx by 2 whole square plus tau xy whole square. Now let us put the value 50.93 by 2 plus minus root over 50.93 by 2 square plus 24.45 whole square. So sigma 1, from this you will get sigma 1 is 60.765 and sigma 2 becomes minus 9.835. Now that is von Mises stress, that is SYT. Yt is what? Syt is von Mises stress is root over, we know that, sigma 1 square plus sigma 2 square minus sigma 1 sigma 2. Just let us put the values. 60.765 square plus minus 9.835 square minus minus, there will be a plus 60.765 into 9.835. So by this, getting this, von Mises stress becomes 66.23 MPa. Now allowable stress, the value of allowable stress is 300, and we get the von Mises stress is 66.23. So this is, this is allowable stress is given. Now what is factor of safety? Factor of safety is 300, that is the maximum limit, divided by applied von Mises stress, and calculating this you will get 4.5. So this is the answer to the problem. Now let us move to the next problem. This is from a thin cylindrical vessel problem. The figure shows a thin cylindrical vessel constructed by welding plates together along the line makes an angle alpha. This is the alpha, and this is the weldment line shown by red color. This is the weld line given. The closed vessel has wall thickness T is 10 mm, diameter is 2 meter, that is R is 1 meter. When subjected to an internal pressure 200 kPa, the magnitude of normal stress acting on the weld is, so along this direction what should be the stress? Now if I take as such an element, then this is what? This is sigma 2, this is sigma 1. Now what is sigma 2? Sigma 2 is PR by T, that is 200 into 10 to the power 3 into 1 divided by 10 into 10 to the power minus 3. This much Pascal. All are in SI, so this much Pascal. That is 20 by 10 is 20 into 10 to the power 6, that is this much MPa. Now as this is a closed vessel, so sigma 1, that is the longitudinal stress, that should be what? PR by 2T, we know, for a closed vessel. So that becomes 10 MPa. So sigma 1 and sigma 2 is known. Now from this we can draw the Morse circle. If I draw the Morse circle, then this is sigma normal stress axis, this is shear stress axis. Now what first, now sigma 1 here is nothing but sigma xx. So this is the sigma xx direction, this is sigma, and this is sigma yy direction. So yy is sigma 2 and sigma xx. Now let us put first sigma xx, that is sigma xx is what? Sigma 1, that is 10 MPa. So here let us mark it, sigma xx is 10, and here somewhere here sigma yy is 20. Now what should be the Morse circle? No shear stress, so this should be the, and this is the x equal to 0 plane, this is the x equal to 0 plane. Now what it has been asked, what is the normal stress along the weld line? Now weld line makes, if I draw a normal to the weld line, this is 60, then this is 90, so this angle will be 30 degree. Okay, so this angle will be not 30 degree, that is normal to the weld line makes an angle 30 degree to the x, along which direction? This is the direction, in counterclockwise, direction. And here this is the x equal to 0 line, This is the x equal, this is sigma xx, this is the center of the Mohr circle. So this green color line is x equal to 0 line. Now, as this makes 30 degree in actual, then Mohr circle it becomes double. So in Mohr circle, we should rotate this green line by 60 degree in counterclockwise. This is, we have rotated 60 degree in counterclockwise. It comes here. This angle is, let me erase it and let me write sigma xx is 10 here for this point, and this angle is 60 degree. Now what is the corresponding normal stress here? Let me project on normal stress this point, project on normal stress axis. So this point, if this point say this is P, coordinate of P denotes the normal stress. Center is C, origin O, this is point A, and this point is point B. Now, value of normal stress on this weld line is nothing but OP. What is OP? OA, OA or OC, OC minus CP. What is OC? This is 20, this is 20, this is 10. Then OC is 10 plus 5, 15 minus CP. CP is radius of this, radius of Mohr circle is 5, 5 cosine 60 degree. That is 15 minus 5 into cosine is half. That is 12.5 MPa. So this is the answer to the problem. That is, normal stress acting on the weld is 12.5. This is a very conceptual problem. Who has gone through my full course class, they can do it easily. The concept is the plane which normal makes an angle, and that has to be double in the Mohr circle. Now let us come to the next. A 3-hinge arc A, B, C in the form of a semicircle is shown in the figure. The arch is in static equilibrium under vertical loads. P is 100 kilonewton and Q is 50 kilonewton. So here it is 100 kilonewton and here it is 50 kilonewton. Neglect friction at all the hinges. Sorry. Neglect friction at all the hinges. The magnitude of horizontal reaction at B, this is point B, is to be determined. Now, first, what is our task? We have to calculate the external reactions first. That is considering the whole arch, whole 3-hinge arch ABC as a free body. So what are the external reactions? RA, RP. That arch is connected to the external by these two hinge A and B. Sorry, A and C. Sorry, I am extremely sorry. A and C. This is not RB. It's a mistake. RC. Now B is an internal hinge. So internal reaction will not come into the entire free body diagram. Okay. So there may be a misconcept. We do not consider the reactions at hinge A in the external one. That is, these two are the external reactions, and we are considering the entire 3-hinge arc as a free body diagram. This is the entire arch as a free body diagram. So now let us apply the equations of equilibrium, that is summation of f of y is 0. By doing that, we get RA plus RC is 100 plus 50. So RA plus RC is 150. This is one equation. Another equation we will get by doing summation of all moments about A is 0. Summation of all moments about A is 0. Doing that, what we will get? RC. RC into distance is 6 plus 6, 12, which is in counterclockwise direction, minus Q into Q is 50 into distance is 6 plus 3, 9, minus P is 100 into 3 is 0. That is 12 RC is 450 plus 300, 750. That is RC. You can easily find what is the value of RC, 62.5 kilonewton. If RC is 62.5 kilonewton, what is RA? RA is 150 minus 62.5, that is RA is 87.5 kilonewton. So now external reactions are known. Now what we have to find? We have to find horizontal reaction at point B. Now to get that, we shall consider the free body one free body of this part, that is this arc. Only we will take the free body of this arc only, AB. Now if we separately draw that free body of this part, that is AB, what we will get? This is point A, this is point B. Now at point B, due to the hinge, there will be two reaction forces, RBX, RBY. This is an internal hinge because at point B there is no connection with the external. So entire free body diagram we will not consider this, but for this part, only internal section, we are taking only AB, then we shall consider the reaction at B. Now here, so this may be a confusion to the students. This P is 100 kilonewton. Here is 100 kilonewton. Reaction force here 87.5, 87.5, and this distance is 3. Sorry, do not mention it here. This distance is 3 and this total distance is 6. Now let us apply the equations of equilibrium, that is summation of f of y is 0. This direction is y. What we will get? That we will get 87.5 minus 100 plus RBY is 0. That is RBY is 12.5 kilonewton. So RBY we have determined, but it has been asked to find horizontal reaction, that is, so no need to do that. Oh no, sorry, we need that. Now let us make summation of all moments about hinge A is 0. What we will get? That is RBY into 6. RBY into 6, that is in which direction? That is counterclockwise, and considering that that is positive, minus RBX, this height, this is which, this distance, this is also 6 meter, it is given, the height is also 6 meter, so into 6, but it is in opposite direction, minus 100 into 3 is 0. That is 6 RBX. 6 RBX is, RBY is 12.5 into 6 minus 300. Minus 300. Okay. That is minus 225. 6 RBX. 375 minus 300. So RBX becomes minus 37.5 kilonewton. So this is the answer to the problem. The horizontal reaction at B is minus 37.5 kilonewton. Now let us move to the next problem. Now let us solve this problem. A vibratory system consists of mass m. This is mass m. A vertical spring of stiffness 2k. This is the vertical spring. And horizontal spring of stiffness k on. The end A of horizontal spring, this is end A of horizontal spring, is given a horizontal motion x equal to a sine omega t. So motion is harmonic. So the system is excited by an harmonic input. Okay. The other end of the spring is connected to an inextensible rope. This is the red one, sorry, the red color one is the inextensible rope that passes over two massless pulleys. So this is one massless pulley and this is another. Assume that, sorry, assume that M equal to 10 kg and K is 1.5 kilonewton per meter, and neglect the friction over pulleys. The magnitude of critical driving frequency for which the oscillation of mass m tend to be extensively large. When the oscillation amplitude is extensively large, when resonance occurs. When resonance occurs. That is R equal to 1. That is omega by omega n is 1. What is omega n? Omega n is the natural frequency. What is omega? Omega is the exciting frequency. What is exciting frequency here? This omega is the exciting frequency. So it has been asked to find magnitude of critical driving frequency. That omega is the driving frequency, input driving frequency. When it matches with the natural frequency of the system, then the amplitude of the vibration of the system will be extensively large. Okay, because we know that x by x st is what? 1 by 1 minus r square for an undamped system. So that is when r becomes 1, so x by x st, when r equal to 1, x by x st becomes what? Like infinity, that is extensively large. Okay, so this is the understanding. Now, so what? That is omega, when omega is omega n, that is the natural frequency of the system. Now what is the system? The system is this one. This is the system, sorry, this is the system. It is stated at the earliest of the problem. That is, the vibratory system consists of mass and two springs, that is 2k and k. Now what is the natural frequency of that system? That we have to calculate. So what to do that? Let me erase this because this is for your understanding only. Okay, now let us consider that this is the static equilibrium position, and from this the mass has been displaced by small amount x, x dot and x double dot. If such, then what will be the disturbance forces? That is, spring is deflected, 2k is deflected downward direction. The spring force will be like this. Let me use another color. Spring force will be like this direction, 2k into x. So this point will move up by which amount? This will move up by amount x. If displacement is x, this point will be move amount by x. If this is goes upward by a amount x, then what is the deformation of the spring? Because there are two ropes, so both will rise by 2x. So total deformation of the spring, here total deformation of the spring will be 2x, because here if this center point moves up by x, in this direction this inextensible rope moves by x, and then this inextensible rope move by x, both will move by x. Then total displacement is 2x, and rope is inextensible, so spring will deflect by 2x along which direction? Along this direction. So here here spring force will be along this direction, that is K2x. So here tension will be K2x. If this point tension is 2kx, then let me erase this. And so here tension will be 2kx and here also 2kx. Now if I draw the free body diagram of this mass, then 2kx, this is 2kx and 2kx. And acceleration of the mass m is x along this direction. Now if I consider this system, or if I convert this system to static equilibrium by using D'Alembert's principle, then what we have to do? We have to add one inertia force m into x double dot, which is opposite to the acceleration. Acceleration is downward direction, so we'll add this. Now this is in static equilibrium. Now this system is in static equilibrium. Now if I make the summation of f of y is 0, then what we may write? We may write mx double dot plus 2kx, 6kx is 0. That is, we may write now. Now let me do it in the next page. That is, mx double dot plus 6kx is 0. That is, x double dot plus 6k by m x is 0. Now uh, now compare this equation with the equation of simple harmonic motion. Omega square x is 0. Then omega n becomes what? Root over 6k by m. That is root over 6 into 1.5 into 10 to the power 3 kilonewton per meter divided by mass is given 10 kg. 10. So 9000 by 10 is root 900, that is 30 radian per second. Okay, so natural frequency of the system is 30 radian per second. So exciting frequency, that is critical driving frequency, omega, must be this value, that is omega should be equal to omega n, that is the answer is 30 radian per second. Okay, we have solved this. Now let us move to the next problem. Band brake shown in figure has a coefficient of friction mu is 0.3. The band can take maximum force, that is the maximum tension T max is 1.5 kilonewton. The maximum braking force F that can be safely applied. So here, if this is the drum, say this is the drum, it is rotating in which direction? It is rotating in clockwise direction. Say tensions are, here it is T1, here it is T2. So it is rotating along T1, so T2 will be more than T1, that is T2 is greater than T1, and T2 by T1 is e to the power mu theta omega. So T max is nothing but what? T2, that is 1.5 kilonewton. Okay, now let us draw the free body diagram of the lever. I am drawing it only here, that is on lever T1 will be along this direction opposite to this, and here it is T2. So if I say this point is A, this fulcrum is A, then if I make moment balance about A, that is summation of all moment about A is 0, then F into 200 plus 800, 1000 is equal to T1 into 200. That is F is T1 by 5. Now T2 is 1.5 kilonewton. T2 is 1.5, that is 1.5. If I use this equation, 1.5 by T1 is e to the power mu is 0.3. And what is theta here? Here theta is 180 degree. theta is, that is pi, and doing that, e to the power 0.3 into pi is 2.57. Okay, so T1 is 0.5836 kilonewton. Let us put here 0.5836 divided by 5, that is 0.117 kilonewton. But it has been asked to calculate the value of F in Newton. So 0.117 kilonewton means 117 Newton. So this is the answer to the problem, and with this we have solved all the problems of GATE 2024. And thank you for watching this video, and please subscribe my channel to get new videos on mechanical engineering.